All right, so let's look at geothermal energy, which is topic 6.10 in our AP curriculum. And our objective for geothermal energy is to be able to describe the use of geothermal energy in power generation and its effect on the environment. We have two vocabulary terms, geothermal energy and hydrogen sulfide. And if we break down the term geothermal energy, that's geo meaning earth, thermal meaning heat and energy. So this is going to be heat energy that's coming from the earth. And it's heat energy that's stored deep in the earth, often in the form of steam, and it can be harnessed to heat and power homes. And so if you've ever heard of like thermal vents or thermal pools, like what we can see here, this is naturally occurring hot springs where heat is being released from the Earth's surface or deep under the Earth's surface, and we can use that steam to turn a turbine to generate electrical energy. So how does geothermal energy generate electrical energy? The same way we've been talking about over and over again. This hot water is steam. The steam turns a turbine connected to a generator and then goes into the electrical grid. That steam can be cooled back down and injected back into the earth as a complete cycle. So hot water or dry steam from deep underground is pumped past a turbine, spins the turbine for mechanical energy, and that generates electrical energy. Where is geothermal energy used most? Well, it's going to be where there's geothermal vents. And geothermal vents often are found at divergent tectonic plates. So we're going to see them in a lot of places around that ring of fire. This map is showing possible geothermal sites because it's showing us where those divergent plate boundaries are. It is not showing us areas that are necessarily actively using geothermal energy. One of the greatest places currently using geothermal energy is Iceland. And they're actually moving toward being almost completely renewable in terms of their power sources. And so we just need to remember that we've got to find places that are geologically active. So you think about, like, say, Yellowstone, there's a lot of hot springs there and geysers, and all of those we could use to harness the energy from those to turn a turbine to generate electrical energy. One of the things that we have to be aware of is that these vents often release hydrogen sulfide, and that's one of your vocabulary terms. Hydrogen sulfide is a corrosive chemical. So, yes, it's great in that we're not combusting fossil fuels, and it's a recyclable, renewable process. The downside to geothermal energy is that it does sometimes release hydrogen sulfide, which is a corrosive material and a respiratory irritant. Okay, there also can be smaller geothermal systems, and so if you've ever gone to the beach, you know what I'm talking about. You know that the top of the sand in the summer is very, very, very hot, but if you'll dig down a little bit with your feet, the sand is much cooler. Dogs do this. In the winter, they'll dig a hole because the earth is warmer than the surface temperature, and in the summer, they'll dig a hole because the earth is cooler than a surface temperature. So even non-geologically active areas can use geothermal heating. For small scale. So it's not going to work to like totally cool off a building in South Florida, but it would reduce some of the cooling costs because it would, transfer some of the heat out of the house into fluid. And so basically it's a water pipe system, and they pump water through tubes both horizontally and or vertically, and then that's also pumped through the house. And so it can warm the house in the winter and it can cool the house in the summer. Again, maybe not necessarily to our cooling standards, but just take some of the energy effort off of an air conditioning system. And so that's a smaller geothermal system. There are benefits and consequences to geothermal energy. The first thing is that it is clean energy because we're not releasing any carbon dioxide, sulfur dioxide, nitrous oxides, any of those air pollutants. It's renewable because we're just using the heat trapped underground from Earth. They're easy to install and manage, and they have a very high net energy. So those are all great things for geothermal energy. It's important to note that geothermal energy is one of the energy sources that is not solar based because it's coming from the actual heat of the Earth's core. Consequences of geothermal energy use are that it is not suitable everywhere. It's not suitable if you don't have for high net energy. Like if you don't have those vents, those thermal vents, you're not going to be able to get high net energy. And then again, it's not going to work completely to cool buildings if you're using the smaller scale systems. It can be very noisy. Those vents, as they release that steam, if you've ever heard like a pressure cooker release, it's similar to that, but on a much larger scale. So it's noisy. People don't like the noise. There are some CO2 emissions that may be a part of the overall picture of geothermal energy when we're talking about, the construction of the sites. And again, like we talked about, that hydrogen sulfide or that corrosive chemical that can be released as the steam is released from the Earth's surface. Okay, so that's a very quick lecture. Your text connection today is to read 15.5, which is one page in the textbook covering geothermal energy, and they'll talk a little bit about Iceland in there. And then answer the checkpoint for understanding questions on whatever page you've been using for Chapter 15 questions. Before we go to the activity, let's take a second. Let's go back over the objective and the vocabulary. So you should be able to describe geothermal energy in power generation and its effect on the environment. And so we know that geothermal energy is a high net energy yield using the Earth's heat to turn steam into mechanical energy by turning a turbine into electrical energy through a generator. And we know that its effect on the environment is that overall it's a pretty clean energy source, but it does release some hydrogen sulfide. It's a little bit noisy, and it's not available everywhere. Geothermal energy, like we just said, for vocabulary is thermal energy or heat energy coming from the Earth's, trapped under the Earth's surface, that can be used to generate electrical energy. And hydrogen sulfide, or other word, is one of the corrosive gases that can be released as these vents are used. Okay, so for activity topic 6.10, what I'm going to have you do is you're going to read an article about the potential for geothermal use in the United States, because we actually have several places that could be very, very useful. And you're going to learn a little bit about a super volcano that's in the United States that could wipe out like half of the world if it ever erupted. And then I want you to talk about, after you've read that article, what is your opinion about developing Yellowstone and parts of Hawaii for geothermal energy sources, and why do you feel that way based on what they talk about in that article, and what we know about ecosystems, environments, but also the overall health of our planet. I want you to make a decision on whether or not you think we should use geothermal power in those areas. All right, so that is going to conclude topic 6.10 for us today.